Page 6. Example 2. Use the product rule to find the derivative of e to the 5x log 3x plus 2. F of x multiplied by g of x. This is a product, so we can use the product rule. Differentiate f of x, which is the first function, e to the 5x. The derivative of e to the x, the 5 is the derivative of the power. 5e to the 5x is the derivative of the first function, multiplied by the second function left alone. Add f of x written down by itself, multiplied by the derivative of the second function, log 3x plus 2. The derivative of log is 1 over, this is 1 over 3x plus 2, but remember to apply the chain rule and multiply by 3, as it's the derivative of the bracket. Tidying up, 5e to the 5x log 3x plus 2 plus 3e to the 5x divided by 3x plus 2. We can collect e to the 5x as a common factor. 5 log 3x plus 2 plus 3 over 3x plus 2. Close the bracket. Example 3, page 7. Use the product rule to find the derivative of 4x to the 5 sine 2x plus pi over 3. Derivative of 4x to the 5 is 20x to the 4, multiplied by the second function left alone. Add 4x to the 5, that's the first function left alone, multiplied by the derivative of sine 2x plus pi over 3, which is 2 cos bracket 2x plus pi over 3. Tidying up, 20x to the 4 sine bracket 2x plus pi over 3 plus 8x to the 5 cos 2x plus pi over 3. Taking the common factor of 4x to the power of 4 gives us 5 sine 2x plus pi over 3 plus 2x cos 2x plus pi over 3. Page 8, example 4. Use the product rule to find the derivative of the square root of 3x plus 5 to the power of 7. Sine cubed 5x. Differentiate the first one. Now, it's not quite as simple as just starting the differentiation. We'll need to rearrange this as a bracket with a power. Square root means power a half, and 7 is here anyway, so that's 7 over 2. That's to prepare it. We can also prepare the sine function. Sine cubed really means the whole function is cubed. So that's these two functions prepared to differentiate using the chain rule. Differentiate the first as 7 over 2 bracket subtract 1 from 7 over 2 is 5 over 2. Multiply by the 3 inside the bracket using the chain rule. Copy the second function as it is, sine 5x cubed. Add on the first function left alone, 3x plus 5 power of 7 over 2, multiplied by the derivative of sine 5x all cubed. Use the chain rule, take the power down 3, copy the bracket, sine 5x to the power of 2. Now multiply by the derivative of what's inside the bracket. The derivative of sine 5x is 5 cos 5x. Now tidying up, 7 halves times 3 is 21 over 2. Write the two brackets, 3x plus 5, 5 over 2. You can write this as sine cubed 5x again. Second term has 3 times 5, which is 15. So we write 15 is the coefficient, 3x plus 5, 7 over 2. Sine squared 5x cos 5x. This is the answer, but we can go further and take out the common factor of the square root of 3x plus 5 to the power of 5. This common factor appears. Also 21 and 15 have a common factor of 3, so we can take out 3 over 2 square root 3x plus 5 to the power of 5. And another common factor is sine squared 5x. Open bracket. Think about what other term you need to get this. We need sine 5x and 7 to make 21. 7 sine 5x. Second term we need 5. 3 times 5 is 15. And we need another bracket, 3x plus 5, because this is the power of 1. Multiplying means add the powers, and we also need cos 5x. Example 5. Find the turning point on the graph f of x equals x e 3x and determine its nature. TP and nature. This is a product, two functions, so we use the product rule to find the derivative of f dash x. Differentiate the first function, which is 1, multiply by the second function left alone. Add the first function x multiplied by the derivative of the second function, which is 3e to the 3x. We have e to the 3x plus 3x e to the 3x. We can set this equal to 0 for stationary points and take the common factor of e to the 3x out. 1 plus 3x equals 0. So this means that e to the 3x equals 0, or 1 plus 3x equals 0 for stationary points. e to the 3x equals 0 does not have any solutions, as the graph of an exponential has an asymptote and never touches x equals 0. Or it never touches y equals 0, so it doesn't touch the x-axis. So this value would have been the y, and y can't be 0. Cannot be 0, as it never touches the x-axis. That's an asymptote. This equation does have solutions. 3x equals negative 1 and x equals negative a third. This is a stationary point. We don't know if it's a maximum or minimum yet. We'll need to continue. This is our derivative, so we'll need to find the second derivative. Second derivative, the first term e to the 3x we can differentiate normally, 3e to the 3x. The second part of it, we need to do this function with the product rule. Again, differentiate 3x, we have 3. Take the second function, the e to the 3x, and write it without changing it. Add on 3x left alone, and the derivative of e to the 3x is 3e to the 3x. Tidying up the terms, 3e to the 3x plus 3e to the 3x plus 9x e to the 3x. The first two terms are e to the 3x. So 3 plus 3 is 6e to the 3x plus 9x e to the 3x. We can use this for the second derivative test. Second derivative test for the nature of the turning point. If f double dash of negative a third, substitute x equals negative a third into this. 6e 3 times negative a third plus 9 negative a third e 3 negative a third. We need to evaluate this to see if it's a positive or negative number. 6e 3 times negative a third is negative 1. 9 times negative a third is negative 3. Negative 3e 1. E to the negative 1 is the same as 1 over e. So this is 6 over e, subtract 3 over e. Since e is a number 2.7 and so on, this is a positive. You can evaluate it on the calculator if you like. Since the function, second derivative of the function is greater than 0 when x is equal to negative a third, this means it's a minimum turning point at x equals negative a third. The last thing we have to do is find out the y coordinate of the turning point. If x is negative a third, we take this and substitute into the original function x e to the 3x, f of negative a third e 3 times negative a third gives us negative 1/3 e to the negative 1, which is negative 1 over 3e. You can evaluate this as a decimal if you like. So the coordinates of the minimum turning point would be negative 1/3, negative 1 over 3e as a minimum turning point.